Hi everyone, my name is Sebastien Boulay. I'm an oceanographer and Director of Business Development at So Far Ocean. Our office is located in San Francisco, but I'm personally based in New Zealand. Those of you that don't know us yet, we're a team of about 50 oceanographers and engineers. Today, I'll be briefly presenting some of the work that our boys have been involved in the small island developing nations. What you see here on the screen is our mission statement. We want to connect the world's oceans. And we are fundamentally doing this to help progress our understanding of science and give the keys to people to understand their local marine environment. Unfortunately, this approach is not simple and presents some complexities. And a big bottleneck, as most of you will know, is the access to in situ data to marine observations. And this is typically made complicated by the cost of the sensors, the complexity of deployment, or the accessibility of the data itself. So our vision really is to empower everyone, scientist or not, to collect the marine data that matters to them. And practically that means offering affordable, convenient, and flexible sensors. This, for example, on the screen is our global fleet of open ocean drifting spotter buoys. We're now living in an era when it's possible to build tens of thousands of remote monitoring and sensing devices that can report the data back to a centralized repository in real time using the Internet of Things approach, if you're familiar with it. And here on the screen is our spotter buoy, which I also have in my office. That's the real thing here. And it's already widely used around the world by weather agencies, research institutes, port authorities, anyone with an interest in the ocean, really. We designed the spotter to be about 30 to 40 times more cost effective than existing weather buoy technology. This was really the first buoy of its kind, the first that was designed by scientists and completely validated by other research agencies. The small size means that we can bring the weight down. You don't need a large vessel anymore, and the instrument can be hand deployed, as you can see on the screen. You can use small vessels of opportunity, and it becomes accessible to untrained citizen scientists. That's especially important at the moment with the travel restrictions due to COVID. Being able to task local people to deploy marine sensors at your research location without having to get on a plane to go to the other side of the world. And you can see here fishermen in Vanuatu or Alaska deploying our buoys on behalf of researchers. What's really exciting too is that we can now scale up observation networks, install a lot of instruments at low cost. And that means we can stop thinking about unique, expensive instruments with no redundancy, but instead think of network of sensors as the instrument itself. We can step away from the hardware and focus on the data and the insight that it provides. Our buoys can be installed as coastal anchored system, that's the traditional way, or as drifters. The exact same buoy can be used both ways. And the usual mooring of ropes and chains can also be replaced with our smart mooring, a sturdy, conductive Kevlar cable providing power and communication to underwater sensors and allowing their data to be accessible in real time through the surface buoy. You can now use your sensors data for real-time operations, quick decisions, and for warnings, for example. And you can, for example, include a bottom-mounted pressure sensor to get real-time water level monitoring for storm surge, tide, or infragravity wave studies. You can also notify the coastal communities during inundation events. But really, it's a sensor platform enabling real-time access to just about any sensor you may need for your particular purpose. And this was the approach taken by the USGS, the United States Geological Service. They installed a few of our buoys with a pressure sensor to monitor the water levels and improve their coastal inundation forecasts. This system allows them to deploy a large number of stations and have, at the same location, easy access to wave and storm surge data. This is particularly important during the hurricane season, as traditional tide gauges are usually installed inside ports, where it's already too late to notify the coastal communities, really. With this system, you can now capture the water level variation further offshore and have enough time to notify the coastal population. Now back to the topic of this talk, which is the access to marine data and affordable technology to island nations. One of the early adopters of the spotter buoy has been the SPC team in the Pacific region, helping other island nations develop and maintain efficient forecasting systems. It's been quite amazing to follow their journey from a couple of buoys in Fiji a few years ago to an established network of marine sensors in many countries, as you can see on the map, which actually probably needs a bit of an update. A lot of these buoys are part of a wide program improving the modeling around the Pacific Islands and funded by the World Meteorological Organization in part. You can see on the right the improvement to the forecasting model by using real-time data from the buoys. Jérôme Aucan, who is also on this panel, leads the team of researchers who are developing this network in the region, including Hervé Darnamian, who created these figures I'm showing you now. So all the credit for this work has to go to the SPC team. I'm just merely spreading the word about that great project. The WMO also recently released a cartoon video that you can see here on the top left to explain to coastal communities that wave buoys should be left alone, and they really are here to help them. And as mentioned, SPC is also doing a lot of work with local communities to make sure they understand how important these buoys are for their safety. They're also thinking outside the box by deploying the wave buoys on fishing aggregating devices, for example. And that's a great way to partner with other agencies like fisheries offices to install more buoys in the region, especially in very deep water, where anchoring is sometimes a little bit tricky. And you can see here that SPC is also really trying to create a coordinated approach to ocean observations in the region. And they're really taking the lead, showing other nations how to implement ocean measurement networks. But really, it comes down to how useful these warning systems are for the coastal populations. And fortunately, over the past few years, SPC have been able to notify them of incoming tropical cyclones, for example. During the tropical cyclone Harold and Iran more recently, that you can see on the screen, you can see that 7-meter swell were measured then and really greatly improved the forecast and the prediction of the swell arrival at the coast. More recently, we were also really glad to see Kiribati see its first wave buoy ever installed. You can see here that the deployment of a wave buoy is a lot easier when you can quite easily just jump in the warm water. And once again, it's a great opportunity to show that it's possible during a pandemic with little to no training. So we're really excited to see the data that's going to come out of this buoy and how it's going to improve the local maritime community. Here's another great story of an organization using our devices to scale up marine measurements, and often in island nations. The coral reefs are on the decline, and unfortunately, everyone here knows that. Aqualink is a non-profit organization delivering our buoys to citizen scientists around the world. They're already monitoring over 200 sites, and that you can see on the map here, with our wave buoys equipped with temperature screens. So that's especially a great story once again, as they managed to deploy this vast network of sensors during a pandemic using people with no training. And more recently, I've been quite fortunate to be part of a reasonably large project funded by the National Science Foundation. Some of the PIs, the investigators, include the directors of the Pacific Northwest, Pacific Islands, and Alaska Regional Observing Systems operating under IUS in the United States. And this project is designed to provide real-time marine devices to underserved, remote, indigenous coastal communities in these 3 regions. The current wave moorings are expensive to buy and to maintain. They're sparsely distributed across the US with very few in these remote regions. And right now, this whole region that you can see in orange on the map is only equipped with about 25 wave buoys. And we're here to change that. The coastal communities over there want to increase their autonomy with regards to the maintenance and the oversight of ocean data collection. And it's obviously much needed for their day-to-day life to use the ocean safely, but also to start collecting important baseline data for climate adaptation studies, for example. And this project is currently at the end of its first year. The focus on collecting feedback from the local partners and establish partnerships to ensure the successful deployment of the devices during the 2nd year, starting in June, July this year, hopefully. Finally, I just wanted to briefly mention the great work done by other sensor groups. We're not alone with this approach of trying to help island nations. There's Hohonu that you can see here on the screen that was created by Dr. Brian Glazer from the University of Hawaii. They are very much following a similar approach to what we're doing at SOFA Ocean by offering low-cost sensors deployable at large scale. And they started reasonably recently and are focused on installing low-cost water level sensors and data analysis dashboards to coastal stakeholders. As you can see here, their expansion was really rapid, and they have already installed dozens of sensors in various regions, capturing extreme weather events and providing large amounts of data to the scientific community. I'll leave it at that for today. Thank you for your attention.